One thing to understand about SQL Server is that very often web apps are actually connecting with a SQL login. Now it's usually either that or an Active Directory account, but particularly in web-facing assets, it tends to be a bespoke database account that the web app is using. Now the database has to store these credentials, so somewhere in that SQL Server we have the login stored with both the username and the password. And as you'd expect, the password is cryptographically hashed, but it is stored in the database. And of course that begs the question, how might we get that hash back out? And then how might we crack it as well? Now in SQL Server, and again, this is Microsoft SQL Server, we have a function called pwd-compare. And what pwd-compare allows us to do is provide a plain text password, and then SQL Server will hash that and compare it to the ones in the database. So let's go and jump over directly into SQL Server Management Studio and see how this works. So firstly, all the logins in the SQL Server can be obtained by running select star from sys logins. So here they all are, and if we give ourselves a little bit more room here, you'll see that we have the name of the login over here in the name column. And if we scroll across a little bit, you'll also see that we have the password. Now for accounts that are actually Windows accounts, so things like this one just here, we don't actually have anything in the password column. This is a Windows login. SQL Server doesn't store the actual password. But in other cases, for local SQL logins, say for the SA account, then yes, the password is stored in the database as a cryptographic hash. Now what we can do is use that pwd-compare function to try and discover which accounts may be using a common password. So let's do this. I'm going to add a where clause to this query, and it's simply going to be where pwd-compare and then the password we'd like to test for, then the name of the password column, which is password, equals 1. So effectively we're looking for where this is true, where there is a password in the password column that is password. Let's run that. And here we have two results. And in fact we can see the one that we just created in the last clip, my login. I've also got another one here that I've used in a previous demo called hacker login. So it's actually found a couple of logins here using that password. Now of course we can always run this query remotely through the web app as a SQL injection attack. And if we run this and we discover that there's a login called my login that already has that password, even if we can't create logins ourselves, so for example the web app is connecting under an account where create login is denied, we still now have enough information to potentially remotely connect to the server. Of course, we've just guessed the word password, and we got it first go because I know that there is an account, in fact 2 accounts, with the password of password. Inevitably though, this would be part of a brute force attack. You'd be enumerating through a dictionary of common passwords looking for whether it's been used in one of the SQL accounts on the system. So that's a more likely scenario in your ethical hacking activities. So that can be a rather powerful approach. And it's a second way of getting remote access directly through to the database. With that now understood, let's move on and start to look at other ways that we can exfiltrate data from this database and just simply replicate it over to another target database.